Welcome. I'm Renee Fry-McKibben, Professor of Economics at the Crawford School of Public Policy at the Australian National University and co-director of the COVID-19 and the Macroeconomy Research Program at CARMA, jointly with Joaquim Vespignani. So we're excited to have you join us for this webinar by Benjamin Wong on Nowcasting the Output Gap. So this is a joint paper with James Morley from the University of Sydney and Tino Berger from Georg August University in Göttingen in Germany. So James and Tino will join us for the presentation. They're in the audience, except James has to go to the dentist in 30 minutes. Benjamin Wong is a senior lecturer and holds a DECRA fellowship at the Department of Econometrics and Business Statistics at Monash University. He also serves as co-director of the Model Uncertainty and Macroeconometrics Research Program in CARMA and has a PhD from the ANU. He has research interests in applied macroeconometrics and time series analysis with a focus on issues related to estimation, inference, and interpretation of sources of business cycle fluctuations. A theme of his work has been the development of tools to inform policy analysis through the estimation and understanding key inputs for macroeconomic policy analysis, such as the output gap and trend inflation. He was previously a research economist at the Reserve Bank of New Zealand and is a regular visitor at central banks and policy institutions, including the Bank for International Settlements, the Federal Reserve Bank of Cleveland, the Federal Reserve Bank of San Francisco, the Federal Reserve Bank of Dallas, the Bank of Canada, the European Central Bank, and the International Monetary Fund. So I'd like to extend my thanks to Ben for sharing his expertise with us. So we'll hear from Ben for about 40 minutes, and then we'll open up to the audience for discussion. So if you'd like to ask a question, there are 3 ways to do so. The first way is to ask a question by using the Q&A function on Zoom, and you'll see a box with the label Q&A on your device. You can type your question into the box, and you can also see questions that others have asked. If there is a question that you would like and you are using a computer, you can click on the black thumbs up symbol to upvote the question, and I will pose the most popular question to the panelists. If you'd like to ask your question via your microphone, please use the raise your hand function on Zoom, and I will allow you to turn on your microphone so that you can pose the question directly to Ben. If you'd like to ask your question on video, raise your hand and also send me a private chat message to let me know that you would like to turn on your video. So before we begin, I'd like to let you know that we are recording this session and it will be available on the CARMA webpage after the event. So as this is a webinar, you won't be in the footage unless I ask you to turn on your camera. So I'll now ask Ben to start his presentation.
All right, thanks, Renee. And I have both Tino and James here. So let me just get my slides sorted out. All right, I gather all of you can see my slides. All right, so thanks, Renee. And this is joint work with both Tino and James, who are with us today. And what we're going to attempt to do is to now cast the output gap. So this is sort of important for central banks in normal times, but especially important right now, given with all the economic data we're seeing, no one really has any idea what the output gap looks like, apart from the fact that it's really bad. Right, so this is the idea that we're really looking at. So we know that central banks, give me a minute, rely on the output gap as a measure of economic slack. So basically the whole idea is the output gap is just some deviation of output from potential output. And if you're above it, the economy is overheating. If you're below it, the economy has still some slack. So the output gap, of course, is unobserved, but it can be estimated using statistical models. So some of the methods you could use are maybe using things like the HP filter or the bandpass filter, which are very common ways to estimate the output gap. Now, if you've known me for a long time, I would not advocate using the HP filter, but there is another reason why I would propose what we're doing today. And one of the things is really comes from some recent work that shows that multivariate models perform well. So a lot of what we're doing today is really building a little bit from this Morley and Wong paper that I have with James in the Journal of Applied Econometrics earlier this year. And what we show is if you bring in multivariate information to estimate the output gap, you can often get much better performance. And the whole idea is quite intuitive. A lot of methods for estimating the output gap tend to be univariate. But if you work in a central bank or in a policy institution, you know that you do not just rely on GDP data. You look at things like, say, the unemployment rate. And what happens very often is people maybe put a HP filter through, look at the unemployment rate, see, oh, is the unemployment rate going down? Is this consistent with the output gap? And then it has some add factor to adjust the output gap. Now, what me and James show in our Molly and Wong paper is it's actually quite possible that you can incorporate this information. And so this is a much more transparent way to build in this information in estimating the output gap. Give me a minute. All right, but what I already want to deal with are actually two specific issues in this paper. And this should not be a surprise to people who work in policy institutions. And it would be quite obvious if now that I stated it to some people when I talk about the nature of the problem. So the first problem really is real GDP is observed with a delay. So no matter what sort of method you use to filter GDP, now if you wanted to get what the output gap today is, GDP is not there. So just think of today is 2020 Q2. We do not observe GDP this quarter, and therefore if you wanted an output gap today, short of finding a way to fill in that real GDP number, there is no way you can do that. And I think this is an issue that we want to deal with in this paper. And another issue is, of course, you're not totally ignorant of what real GDP is, even if it comes out with a delay, because a lot of macroeconomic indicators actually are released much earlier than GDP, and they are released at higher frequency. Now, some of this data are daily, but in this paper, what we're going to deal with is monthly data. And so what's going to happen is within the quarter, we do not know what GDP is, but you're going to be able to observe monthly information of, say, like unemployment, industrial production, inflation, et cetera, et cetera. So one of the things we really want to tackle in this paper is there a clever way to use this information? So this is me lifting a picture of The Economist, and I think this really sparked our interest in really looking at the problem when Tino visited me and James in February, which seems like a long time ago when all of us could travel. But you can see, so this is initial claims in the US. So you can see this indicator tends to go up in recessions, but in this corona crisis, this thing hit a number like 3.3 million, making the rest of the series look like a noise with a very small variance. So the question we really wanted to ask was, can we that really motivated us was we see a number that looks like this. It looks disastrous. I mean, can we somehow use this to build a model in order to help us tell us something about economic slack? This is another picture. I lifted this off the FRED database. And so this is industrial production in the US. And you can see, obviously, in the last month, in the last couple of months, this measure has totally collapsed. And so there is actually high frequency information that can tell us how the economy is doing, even if we don't observe real GDP. So this is really our contribution. We're going to propose an approach to estimate the output gap, and we're going to do it given two things. First, the mixed frequency nature of the problem, so that in the sense that we get monthly information, but we really want to filter something that comes up quarterly. And also that there is a delay in the release of real GDP. So in some sense, we are really nowcasting. And so we just differentiate between nowcasting and forecasting in the sense that forecasting is to predict a value tomorrow, but nowcasting is really trying to predict a value right now. So what we do, we're going to borrow from some recent advances in mixed frequency modeling. More specifically, I'll go into more detail. We will specify a mixed frequency B bar, or I'll call it MF B bar. We're going to cast it in the form of Molly and Wong, my Journal of Applied Econometrics paper with James. And thereafter, once you cleverly find a way to specify the model, everything else follows. We'll implement shrinkage, we'll apply the BN decomposition, we'll get the output gap. Another thing that we're going to do is we do know that you can use conditional forecasting techniques to update the model for the monthly data, and we're going to use these conditional forecasting techniques. So I cite Wagner and Jha there in order to work out a way of how you could update the model for release new monthly information, but also to consider scenarios. All right, so the key takeaways. We show that it's possible to estimate or nowcast the output gap by updating information from a bunch of monthly indicators. And we can do this even without needing to observe real GDP today, which is actually the nature of the problem. Now, monthly information do contain useful information that can help us nowcast the output gap. So that's good news, because you don't want to be doing all this and there's no information, the monthly information. So we'll show metrics how these monthly information actually do contain useful information. Now, the output gap from a mixed frequency B-bar looks a lot like the one that we obtained from a quarterly B-bar. So this actually just provides a bit of a sanity check that what we get from the mixed frequency model is not too crazy. If, let's say, if you conventionally use a quarterly B-bar, you would still get something that looks fairly similar. Now, one of the most surprising things is conditional on observing all the monthly information. Observing real GDP adds little or nothing for nowcasting the output gap. I'll go a little bit into why, but what we're trying to say here is it seems that once you observe all the monthly information, so right now it's 2020 Q2, hypothetically, if you observed all the monthly information in 2020 Q2, it seems that we don't even need to observe real GDP in Q2 in order to be able to successfully nowcast the output gap. So we have this run of karma events where we are talking about COVID-19. So we're going to do a real out of sample exercise in looking at the COVID-19 crisis with our model. And so I'm going to throw a number out here. As it will be clear later on, this number is now 2 weeks out of date. I got a number 2 days ago, but James told me that CPI came out this morning. So my number is now 2 days out of date. But what we're going to show is our out of sample exercise for COVID-19 shows that the output gap right now, 2020 Q2 in the US, is about minus 28.8%, which is very negative and very large. All right, so this is the roadmap. I'm just going to briefly talk about some approaches to mixed frequency modeling for people who are not very familiar. It's not going to be a lit review, but it's just going to give you a flavor of how people do it and where we fit within this paradigm. I'm going to talk about our approach, show you some results. We'll do the COVID-19 application. So I think people are interested of how we got to minus 28.8. And then I'll just have some concluding remarks. All right, so mixed frequency analysis. We do know that mixed frequency models have been used to nowcast GDP growth, but to our knowledge, we haven't really seen how these methods have been used to apply to the output gap. Now, there's this paper by Bambura et al. That distinguish between partial and full models. So partial models include models like bridge equations, MIDAS, which is a mixed data sampling. The MI comes from here and the DA comes from here. That's very good marketing. But really, partial models tend to be more single equation like. While full models, we would classify them as models that have multiple equations, like mixed frequency bars, which we're using, or dynamic factor models. So this is an example of a bridge equation. So you have the change of GDP, a constant, and then you have some lags of GDP, and you have some aggregation rule that aggregates this monthly data. And what you're going to do is once you aggregate, you're just going to plug this in and you'll be able to forecast real GDP growth. Now, a very intuitive example is, let's say, if you had data that was observed monthly and you could be taking averages of the months to get quarterly data. So that could be an aggregation rule, but in general, this is very general. Now, MIDAS approaches, would say you could do something like that, but where Eric Giesel has done a lot of contributions to the Midas literature, what you're going to do is you're going to set some sort of almanac function here in order to model this relationship between the monthlies and quarterlies. So this function here tends to be something that, say, exponentially decays or something, which helps you, which really, if you think about it intuitively, are just really pinning down some weights for this monthly information. Now, you don't have to do a restricted form of this almanac operator. You could use like what Ferroni et al. Do, where they have a U-Midas variant, where you can just estimate all these parameters. Of course, the difference between putting some restrictions here is this model might be over-parameterized. I mean, they are sort of in the same spirit. Now, those are single equation approaches. We're not going to use them. Instead, we're going to use a multiple equation approach. And there are sort of two ways how you can think about multiple equation with the mixed frequency literature. You could either think that the economy evolves at the highest frequency, and this is what Schofider and Song do. So basically, you have monthly data, you have monthly, and then you have quarterly data, and then you treat the monthly observation of the quarterly data as sort of latent variables or missing observations, which is what Schofider and Song do. Now we're going to take the other approach. This is very similar to what Giesel, Brave et al. And McCracken, Ouyang, and Decomposition, which we are going to follow this approach quite closely. We're going to take a Midas-like approach, but we're going to specify the model at the lowest observed frequency. So instead of specifying a model in the monthly frequency, we are actually going to specify a model at the lowest frequency, which is going to be at a quarterly frequency. So as I said, we're going to follow quite closely how McCracken, Ouyang, and Decomposition consider Bayesian estimation of a mixed frequency VAR with unrestricted parameters. All right, so this is what we do. So this is our proposal. We're going to specify a BVAR that looks a bit like a McCracken et al. Once in that form, we're going to apply the BN decomposition. So the BN decomposition is just a means of getting trend and cycle, and I'll go a little bit into why that happens. And based on the BN decomposition of the mixed frequency BVAR, we're going to get real GDP, the trend, and the cycle. So what happens, what's going to happen intuitively is once we specify a BVAR that looks a bit, a mixed frequency BVAR that looks a bit like McCracken and L, what happens after that is going to be pretty close to what me and James do in our paper earlier this year. All right, so for those of you that are not familiar, I'll just quickly go through what is the BN decomposition and how you can actually separate a time series into trend and cycle. So the whole idea of the BN decomposition is you want you are sort of defining the trend as the long horizon forecast minus any deterministic drift. So the trend at time t, which we label tau t, is just the limiting forecast of information at time t of the time series yt plus j as j goes off to infinity. So the whole idea here is in the long run, there is no more cycle, and at time infinity, you're back to the level here, which is the trend. So this is quite in the spirit of what Nelson describes his BN decomposition. Why not define the trend as simply a long horizon forecast? Rather than being fixed and predetermined, the trend shifts with each data point revealing new information about the future. So basically at time t, you observe some information. With that information, with a forecasting model, you forecast where the level of y goes in infinity. That will be the trend at time t. Now you go to t plus 1, you observe some more shocks, and with that you form another forecast. There'll be a trend at time t plus 1. And so all you need is really a forecasting model to specify this. So this is how the BN decomposition works out into a trend and cycle. So consider the following AR or VAR-P. We can always cast a model like this into a form that looks like this. This looks a bit like an AR1. This is just xt in state space form. So if xt equals f, xt minus 1, and some shocks here. So So now you want to work out the long horizon forecast, and one of the variables here is real GDP growth. So basically, you want to aggregate all the changes, and then you add this up, and then this becomes the level. So how would you do this? So this GDP growth here is an element in this XT matrix. So you start off by writing this. So you make a forecast of t plus 1 after observing t. That's just f of xt, because the expectation of this thing is 0. T plus 2, it will be f squared. In fact, t plus j is going to be just f to the power of j. So these are the 1 step ahead, 2 step ahead, j step ahead forecast. What you're going to do is these are changes. So you want to sum up all the changes. So basically, you're just summing xt plus I as I goes from 1 to infinity. So this will be just like f times x plus f squared times x plus f cubed, etc., etc. So you can recognize that this is just a geometric sum. So f1 plus f2, blah, blah, blah. And that is just f times I minus f to the inverse of xt. So these are the sum of the changes. So what you're going to do to get the level, because these are just the sum of the changes, you're just going to add this back to xt, and this is a vector now. This is lt, and this is ct, which is just the negative of this. So you can see that if I sum these two up, I get that xt. So to get the output gap, let GDP growth be in the kth position and Sj to be a selector matrix. So basically, you're just getting the kth element here. So the output gap is just one element of this C matrix over here. So basically, I'm just pulling out the k element here. And so this just becomes a number. All right, so this is the output gap. So we have actually showed that with a conventional B-var estimated on quarterly frequency, the above expression can be used to obtain an output gap. So I've done this with James and also with Tino and his student Julia Richter. We have also managed to successfully estimate both an output gap and a financial cycle, just specifying a conventional B-var. Now, the challenge now is all this is actually fairly standard. The challenge really is how you're going to specify this xt vector, taking into account the mixed frequency nature of the problem. So we're going to specify a system along the lines of McCracken, Ouyang, and Sekapozin. So first, we're going to stack the k monthly variables as this. So the notation is a little bit crazy, but V is just a month within the quarter. So MT minus V is, we just stack all the monthly information of a certain, all the variables in a certain month. So this could be like, say, January industrial production, January unemployment rate, January Fed funds rate, blah, blah, blah. So this, the tilde here represents it being the mean. And then once you have the months, you're going to stack the months within the quarters. So you can see this is XT. So we're going to just define this as YT. So GDP growth is the last element here. So you have month T minus 1 plus 1/3, T minus 1 plus 2/3. So this is the first month of the quarter. This is the second month of the quarter. This is third month of the quarter. So the only quarterly variable we have in our system is just GDP growth. So you have a bunch of monthly information here, which you stack like this within the month itself, and then you stack like this within the quarter, and then you have YT. And so if you have YT, then really you just specify a var on YT. And so you can just freely fit a var here. So this is going to be the system we estimate. So we're going to place a natural conjugate prior to just put in some shrinkage. So basically, this is fairly standard where all the var parameters are centered around 0. You shrink the longer legs closer to 0. And we're going to follow my paper with my earlier paper with James, where we're going to set the shrinkage by minimizing the one step ahead out of sample forecast error. So the whole idea here is overfitting is going to compromise your out of sample forecast. So by setting the shrinkage to minimize the out of sample forecast, you're effectively mitigating overfitting. So post estimation, once you have all these YTs, you stack all these YTs that looks like that, and this is XT, and there you go, you're off to the races. You can use these expressions over here. All right, so this is just an example to make it a little bit more concrete what I'm talking about. So let's say in 1995 Q1, Y of 1995 Q1 will have the monthly variables in January, the monthly variables in February 95, the monthly variables in March 95, and then GDP growth in 1995 Q1. 1994 Q4, which is the previous quarter, will have October, November, December, and then the quarterly value. So you can see that if you stack them like that, etc., then if you run a var, you'll be running this against sort of these things here as the lags of this thing here. So if you do this throughout the sample and stack this appropriately, you just specify a mixed frequency var that you can use to obtain the output gap through the Barrett-Nelson decomposition. So I want to spend a little bit of time talking about the updating problem. So this is how we're going to estimate the model, but the question is how you're going to update the model for new information. So this was what we started with, xt equals f of xt minus 1. So we know the output gap has an analytical expression that looks like this. So now let's say the last quarter where we observed all the information is time cap t. So we want to the output gap at t plus 1. All right, so this is just rewriting the expression here, but I am just changing the t subscript to a cap t plus 1 here. Now, this thing here, you can rewrite it over here. It's just equal to this because xt plus 1 is just f of xt plus he cap t plus 1. So you substitute this. So this expression here is very useful because it effectively shows you that the nowcast of the output gap at time cap t plus 1 is dependent on two things. It's dependent on all the information you've observed in the last quarter, that's cap t, and it's dependent on the information or the shocks that you see at time t plus 1. Now, at time t, the expectation of these shocks, t plus 1, is 0. And therefore, without any new information within the quarter, just the information you observed last quarter, this is the output gap. But of course, we know that as new information gets sequentially released within the quarter, this is no longer 0. And the reason is because as information gets released within the quarter, the epsilon t plus 1s are sort of being realized. And so the problem is that we are trying to solve here is if you observe some of these epsilon t plus 1s being observed, how are you going to map this back into a forecast into this form here? And then once you nail down a forecast for this thing here, or nowcast for this guy here, then you can pretty much get your output gap at time t plus 1. And so this actually boils down to some information that you can use from the covariance matrix here. So the question here is, that I'm going to tackle is how are we going to update this t plus 1 here? All right, so let B be a lower triangular Cholesky factorization of sigma. It doesn't need to be lower triangular. This is not structural decomposition. It works with any decomposition, but this is just a special case that's very convenient for us to work with. All right, so these are our monthly variables in the first month, second month, third month, and we are updating this vector. All right, so I'm going to specify epsilon cap t plus 1 is equals to b zt plus 1. So to preserve the covariance structure here of the forecast errors. All right, so the whole idea here is this. The Cholesky structure here is very convenient. So let's say this piece of information was revealed within the quarter. All right, so as epsilon t cap t plus 1/3 is available, you will just solve for zt t plus 1. That's quite easy because you can see that if you expand this, this is equals to just b11 times this. So basically, you can just solve for b11. Now, once you do that, no, you have b11, so you can solve for this. So once you solve this, you can go back and update the whole of this vector because all these things are all functions of z1 t plus 1. So that's what you do when this observation becomes available. Now let's say the second observation becomes available. Now you have this and you have this. Now what you're going to do is you have two equations and two unknowns. You're going to solve for zt plus 1 and z2 t plus 1. And then with this, all these things here are functions of Z1 t plus 1 and Z2 t plus 1. And with this, you update the rest of the vector. And once you update this, you can once again use this expression here to nowcast the output gap. Now, what I've just mentioned is just a special case of conditional forecasting that Wagner and Jar show. So the Cholesky case, the Cholesky structure here is actually very convenient because we're actually working with a system where the data is actually sequentially updated one by one. So these zeros are actually very neat. But in general, you can actually use this structure to do conditional forecasting with Wagner and Jar. So it doesn't need to be a Cholesky. It's going to be a little bit more complicated. But what I've showed here is a special case. So we're going to use the conditional forecasting techniques to also set general scenarios. So basically, you can use conditional forecasting like this to update this vector here, but you can also use this to set general scenarios for the output gap on top of updating. And I will use this quite heavily when we do the COVID example. All right, so this is the empirical application. We have US data from 1967 to 2019. So we really wanted to end the estimation before COVID-19 because God knows what's going to happen after that. So monthly variables, we have some financial variables with interest rates. So we have the Fed funds rate, the term spread, the risk spread, stock returns. We have the labor market. So we have initial claims, where was the horrific picture I showed you earlier of how many people were filing for unemployment benefits. Unemployment growth, unemployment rate. We have other macro indicators like consumer sentiment, industrial production, CPI, housing starts. And so the only quarterly data we have is real GDP. So we have 11 monthly variables and 1 quarterly variable. Now, when you consider that these monthly variables are observed 3 times within the quarter, this is not quite trivial. This is actually, in some sense, you can think of this as like a 34 variable VAR, which is why we really need to bring in the Bayesian shrinkage here. All right, so this is the comparison of the output gap that you get from this model. So this is the output gap that the blue line is the output gap we get from the MFB bar. So you can see that we are reasonably happy that it tracks all the recessions. It looks like what you will get from a conventional output gap. And all this just comes from estimating the B bar and then applying shrinkage and the Beveridge-Nelson decomposition. We have a quarterly variant of this model. So this is just estimated the way that me and James did in our Journal of Applied Econometrics paper. Basically, instead of treating the information as being observed monthly, we treat it as being observed quarterly. So that in that case, that would be a 12 variable VAR. So you can see that the mixed frequency VAR tracks the quarterly VAR reasonably well. So this is why the correlation of how much the within quarter information matters. So if you don't have any within quarter information and you compare the output gap that you get and you compare it with the output gap that you get at the end of that quarter, the correlation is actually quite high. And the reason why the correlation is quite high is because the output gap actually embeds a lot of persistence. And that persistence is actually being captured over here, right? So you can see that this is like F squared, later you get F cubed, F to the power 4, etc. Now, if you observe the first month variables in the first month of the quarter, that correlation goes up slightly to 993. If you observe the second month, it goes towards 1, and with the third month, you might as well just say and all this happens. So this is actually due to rounding. It's more like 0.9999 something. But what we show here is if you observe all the monthly information without actually observing real GDP, you sort of already can nail the output gap. And the reason is because it's persistent. If you look at, say, the correlation and you do the whole exercise with output growth, you find that this is actually much less reliable than the output gap. And the reason is because there is more persistence in the output gap relative to output growth. But you might ask, I mean, if I really get 0.982, or how much of this is really useful, right? And the way to think about this question is you want to think of whether that additional information was actually helping you reduce that forecast error. So this is the average the mean absolute error away from the output gap that you get at the end of the month. So there are the various variables here, and they are sort of ordered in the way that they are being observed. So basically, you get all the financial information, then consumer sentiment comes out, the employment report comes out, then inflation, IP, housing comes out. So they are roughly, the order roughly corresponds to the order that these variables are released within the month. So you have month 1, month 2, month 3. So you can see that as the bar goes down, it means that you're much closer to the actual output gap that you observe at the end. So you can see that conditional on observing all the information, this bar here is very, very tiny, which is sort of what I was saying, that you sort of really get the output gap even without seeing real GDP. But you can see some information is probably more useful than others. And the way you want to see this is if you see a sharp drop here, that means that information was useful, because it was useful in reducing the extent of the forecast error. So you can see that within the first month, observing observing initial claims is really, really useful, because you can see a huge drop here. And what you can see in the second month seems that observing consumer sentiment is useful, but of course it still continues to fall. And in the third month, it seems that the more information that you observe, the sharper your inference becomes. But of course, are these statistically significant? And we can do a Debo-Mariano test to do this. So the Debo-Mariano test here is really whether the nowcast here, and you observe the next piece of information, whether that reduces the mean absolute error by a statistically significant extent. So you can see that in the first month, as expected, you can see initial claims really matters. And then in the second month, consumer sentiment and a lot of the labor market stuff starts giving you a lot of information. But once you get to the third month, you see a lot of zeros here, which means that a lot of this information is really helping you now cast the output gap a lot better. So we did a couple more exercises. We allowed for a break in the drift. I'm not going to talk about this. And then we also tried this with real-time data, and it seems to do reasonably well. But what I really want to spend the last 5 or 10 minutes is to really go through our COVID-19 application. All right, so obviously economic data has been looking quite unprecedented, and what we're trying to do in this paper is to really see how we can use this information to learn something about this current crisis. All right. So I just want to remind all of you, in January and February, things were still looking great. Things actually only really fell apart in like the last 2 weeks of March. So really, most of Q1 was actually tracking all right until the last 2 or 3 weeks of March. And you can see here, if we look at our model, what it implies for the output gap or output growth, with January and February's information, output growth is sort of like the average sort of output growth that you expect from the US, and the output gap was about 3. Now, in March, sequentially, all this information came out, and you can see that a lot of the output gap actually was still very close to 3. It was only with the release of the initial claims data that the output gap really fell from 3.2 to 0.8. And then the release of unemployment growth, that this thing fell further to minus 3.4. And then you had some change over here, but really once you saw IP and housing starts, our final estimate for 2020 Q1 is about minus 4.6%. But you can see that the information that really matters was really all the disastrous stuff that really came out in the last 2 or 3 weeks of March. Now, if you look at output growth, this is roughly the same picture. I mean, GDP, the forecast of GDP growth was sort of going down. We knew that the stock market collapsed, the consumer sentiment went down, but initial claims, we saw that disastrous number, and over here it fell. And we get to the final estimate of minus 20.7% at the end of the quarter. Now, it turns out that real GDP growth was about minus 4.6%. So this is the advanced estimate. I know it's been since revised to about minus 5%. So really, this forecast here is actually quite off the mark over here. And actually this comes from the fact that there's actually more correlation in the output gap, more persistence in the output gap relative to output growth. But I want to talk about 2020 Q2. So this exercise was done 2 weeks ago. All the April information was out. We didn't have any May information yet. Of course, that has changed, that some of the May information has since come out. So January, February, March, April, all this is data. All right. So I'm talking about a forecast that we can get from the model. And so I compare two things, a conditional forecast and a scenario. So if you just freely estimated the model from its April values, this would have been the forecast from the model. And actually some of these numbers start looking a bit crazy, and they are a bit crazy because some of the data is a bit crazy. So you can see that if you freely let the model estimate the output gap, the forecast of the federal funds rate actually goes to like minus 18.2%, and it goes to minus 29.4%. So in this sense, we think that it's actually much more sensible to use a scenario nowcast in order to give us an estimate of the output gap. And we construct these scenarios just based on previous recessions. So Tino did this in a previous paper where they looked at how macro variables behave during a recession, and then we scale it up by some number to bring in some sort of to sort of hammer in the severity of the COVID crisis. So you can see that these scenarios are numbers that we set. Now, my point here is, of course, we can debate about how these numbers came about, but the scenarios are definitely going to have to be more sensible. So basically, you can see here, we're just basically saying that the Fed fund rate stayed where it was. The term spread doesn't get to crazy numbers. And so once you set these scenarios, and or you do not set the scenarios, what do you now cast for the output gap for 2020 Q2, which is now? So we just, without any April information, the estimate of the output gap is actually minus 12.4%. Now, if you observe the April information, and just the April information, so this will be just the first column here, you actually get a number that's like minus 39.5. Now, if you bring in the scenario to fill in numbers for both May and June, we get something that looks a bit more reasonable, like minus, or we can debate what's more reasonable, but we get something like minus 28.8. Well, I would say that the scenario is more reasonable, just given that these forecasts of these numbers look a bit crazy in order to give you the 39.5. So what I did 2 days ago was I updated the data for the financial information in May, and I also updated the data for the employment report. So you might remember employment growth, unemployment, initial claims all came out. So if I did that with the May figures, without the scenario, I get an output gap of minus 29.5. Now it seems that even if you add a scenario, we don't get something that's drastically crazy. Actually, this is rounding. It's more like 29.98 something. So this is actually very close here. So it actually leads us to think that early in the quarter where you have less information, it actually makes sense to specify a scenario. And actually, as more data reveals itself, maybe the scenario is not so crucial in how you now cast the output gap. So the estimate 2 days ago is minus 29.5%. I know CPI came out this morning and we did not update it, so who knows what happens, but I think it's very close to the number we have over here. And so I would be very surprised that that number changes very much with the CPI release this morning. I'll just make some concluding remarks. We show how one can now cast estimate or obtain the output gap by utilizing the flow of higher frequency data within the month. And it seems that the structure of the problem does not require you to know what is real GDP in the current quarter. Now, the out of sample exercise for COVID-19, this is 2020 Q2, that's a typo. We find that, that our current estimate of the output gap is, I should say, somewhere in minus 29 or minus 30%. All right, so I just want to shamelessly plug this, that we have a website associated with our numbers that we call it www.outputgapnow.com. And if you click this, I will have to share this on Zoom. Let me share this. Yeah. So this is outputgap.com. You can see that this actually already incorporates our latest number, 20, not our latest number, 28.8. So that was the number 2 weeks ago. And you can see that the output gap is very negative, and the rest of history is starting to look like noise. Now, we actually have a slider here where you can play with these numbers here. So our intention is to try to update this as more data comes along. But otherwise, thank you very much, and happy to take questions.
Okay, thank you, Ben. That was really interesting. So we have, I'll just remind the audience that if you'd like to ask a question, to write your question in the Q&A panel, or to raise your hand and you can turn on your microphone. But our first questioner is Joaquim Vespignani, who is a co-director of the program. Joaquim?
Hi, Ben.
Yeah, hello.
How are you? Okay, very nice presentation. I really like the paper.
Mm-hmm.
My question, and probably is more than a question, is a moving forward sort of thing, or next paper, is that, you know, the shutdown or the COVID-19 crisis, basically we know that affect industries very asymmetrically.
Yeah.
And you know, if we, I mean, another way to think about that is just to go by and look industry by industry.
Yeah.
What I'm thinking is that there may be the opportunity to further decompose for the next exercise. Once we know which industries were affected most, maybe for the next quarter there is a possibility to use you know, to use any evasion restriction to include I mean, to think about you know, in terms of factors, just to try to see which variables are actually more useful during this crisis. And that's why probably once we know that after the first quarter or the second quarter, then may be able to improve the nowcast, right?
Yeah, yeah. No, I think that makes sense. So I would, so actually we did a quick paper with me, Heather, Farshid, and Giovanni, where we looked at actually manufacturing sectors, different employment sectors in Australia. And you're absolutely right. And but I think as an aside, I think this actually gives a reason why the conditional forecasting tool might be actually quite useful in a time like this, because as you said, a lot of industries are affected asymmetrically. And I think what you want to do is you actually have some information, right? So let's think of, like, say, Australia. We know, like, for example, travel and accommodation, I mean, they have been absolutely decimated, right? Arts has been decimated. I mean, well, I don't want to talk about universities, given I'm being recorded. And you can sort of bring in this sort of information through the conditional forecasting tool, right? So I'm not directly answering your question, but I think it fits into what we're trying to do, that I think if you know that there is information about how different variables or different industries are impacted differently, I think this is sort of the tool that you want to use rather than to just rely on the unconditional forecast that is sort of is the model is just iterating itself.
Yeah, one idea that occurred to me is that maybe what you can do is just to run the exercise for the growth value added with the same code and with the same variables, but for each growth value added for each industry, and that is going to give you an idea which industry is better predicted or worse predicted in this particular scenario. And that's, you know, it will allow you to put some restrictions about how because as you say, I mean, the airline industry disappeared, right, for a quarter.
Yeah, and that's true. You have some information. I think in general you should use it.
Yeah, but also there are
Mhm.
there are other industries that actually benefit from
Yeah.
the crisis, right? Because they are taking, for example, big supermarkets maybe benefit because the small ones are closed, and you
Yeah.
know, and that's
Yeah.
why it's not that it's only one direction the problem. There
Mhm.
will be some benefits, some, you know, and
Mhm.
I think that will be a valid exercise. But that just
Yeah.
of course this is when we have a little bit more information,
Yeah.
and maybe
Yeah.
for
No.
the next quarter, the
Mhm.
quarter after the one that you are predicting, right? Q3.
Yeah. Yeah. All right. Thanks, Joaquin.
Okay, so our next speaker is Warwick McKibben.
Mhm.
Can you hear me, Ben?
Yes, I can.
Yeah, thanks very much.
Warwick.
Good to see you.
Yeah.
So I like the paper, but I have a conceptual question.
Yeah.
If you look at the output gap you're calculating, it's we know output has fallen, right? So we know demand has collapsed. We also know supply has collapsed. The question is, potential output could have actually collapsed. If you take the estimates of your output gap and stick them in any of the inflation equations that people have developed, you're going to get a massive deflation in that sort of equation.
Yeah.
So the question is, can you use the price data as it gets revealed to back out what the change in real output must have been if those previous inflation equations are still valid? And so somehow add information from observing inflation that the output gap couldn't have fallen 28%. I mean, I just don't believe that. So the question is, can you use that?
Yeah, so we actually already have CPI inflation in the model. And as you know, CPI inflation doesn't seem terribly correlated with economic slack. So within the context of the model, it's not adding a lot. But I think you do bring up a more conceptual issue is we are trying to say something about something that's fairly unprecedented, but I mean, the model is linear, right? And when some of these things happen, I mean, I do think that's partly why we have to use the conditional forecast, because I think you see some of these linear forecasts are like going all over the place, right? Like, for example, if say the output gap went down by 40%, will we expect inflation to go down by 10%? I mean, at some stage, you must think that the linear relationship must break down, right? I mean, I take the point that it's probably useful to condition some of this information, but I think when you have large shocks like that, I think we need to think a little bit harder what to do to say something useful.
Thanks.
Yeah.
Okay, I'll now ask Lauren Ferrer to turn on his video to ask his question.
Yeah, hi, hello to all from Paris.
Hello.
So very good presentation, Benjamin, very insightful. So I have perhaps two comments and maybe one question.
Yeah.
First of all, the thing is that when dealing with the output gap, the tricky thing is that the output gap cannot be observed. So there is a question about the benchmark. So what is the benchmark when you compare your model with an existing output gap? I think you should not compare necessarily with one of your previous paper, but maybe to a benchmark that people have in mind. And I'm thinking about, for example, the CBO benchmark. The CBO benchmark, you know, the output gap. So that will be perhaps much more convincing. That's the first point. My second point is that in the data, I saw that there is a CPI in the monthly data, right?
Yeah.
CPI inflation and also the federal fund rate. So I would be tempted to delete this variable, maybe because they are quite a bit endogenous, and maybe to keep this variable to check if your model is able to predict CPI in a kind of Phillips curve approach, and if your model is also able to predict the federal fund rate in a kind of Taylor rule approach, that could be a kind of robustness check of your model, and that could be also much more convincing. And that was my second point. And my question is about GDP. You said at some point that there is no marginal gain of adding GDP in your model. Is it correct? And can you show us
at the end of the quote.
some graph, or I don't know, some information on this? Thank you.
Oh, sorry. What was the last part? I didn't quite get the last part.
No, sorry. The last part was saying, okay, you say that GDP does not really contribute to the estimation, to the nowcast. So are you able to show us that it does not contribute by showing a graph or estimating some contribution, in fact?
Oh yeah. Okay. Yeah. So sorry. So I should nuance it. So what I said was within the quarter, if you do not seem to need to observe GDP in order to nowcast the output gap. You definitely still need GDP because without GDP you can't estimate the model. But I think this is the graph that so if we observe all the monthly variables without GDP, our correlation with what you get with what you would have if you observe GDP is nearly 1. In fact, this is a rounding thing. It's like 0.999 something. So it seems that the monthly data is really giving you all the information that you need about the output gap, that you don't actually need GDP to estimate to get a more precise estimate in that sense. Yeah.
Okay.
All right, thank you.
I don't think that we have any more questions. The questions that were posed in the Q&A seem...
I think that it was okay at something, right?
Yeah.
Oh, it's gone, yeah.
But anyway, maybe I will read out to you the 2 questions and you can speak to them. So from Oki, I wonder whether your methodology can also improve the mid and long-term forecast of the output gap. I also wonder if you could try to construct the monthly output gap based on your methodology.
Yeah. So you can't construct a monthly output gap based on the method because, and this actually goes back to a point I made earlier in the paper, we are actually specifying the model in a quarterly frequency. It's possible if you use the other approach that Shofida and Song do, where they treat GDP growth within the month as missing, and I think that could be something that you are thinking about, but I think estimation there's a little bit uglier, so we opted for this. So but just to answer your question, we can't, but I think I have some idea how you might be able to do that.
And our last question, just to finish off, start with first, congrats on a great paper. A clever combination of clever tools, some of them are yours, and from a policy perspective, very useful to have some sense of the data in an environment of huge uncertainty. So in your scenario, was it just the federal funds that you altered because it was clearly out of bounds, and were there others?
It's not just the federal funds rate. There were others, and clearly, I think that goes a little bit to my comment about non-linearity with Warwick. I think a lot of the economic data not right now is unprecedented, and they look a bit crazy. And I think when you have a multivariate system, when one thing goes crazy, everything goes crazy. And so to answer the question, in our scenario, we actually had to put in conditional forecasts for many other things other than the federal funds rate. Now, I think it's we are quite comfortable in the sense that it seems that once you observe more information, it doesn't seem that whether we set a scenario or not matters very much. Like the last estimate I showed you was like minus 29.5 relative to minus 30. That's not huge. I mean, of course, there's still June's data to go. But I think that also shows that maybe the scenario, how you specify the scenario may become less important as you have more information, which sort of makes sense, at least from an econometric perspective.
Okay, great. Thank you, Ben. So
thank you.
One for all the questions as well. So I think we've come to the end of this webinar. So it's been a pleasure to spend the last hour with you and also with James and Tino in the background. Our next event will be next week. Is going to be a webinar by Giovanni Cacciano from Monash University on the global effects of COVID-19 induced uncertainty. So give up some good karma at home and give Ben a round of applause. We know we can't see you, but the world needs good karma. So, yes.
All right, thank you.